is here. It's a little over 7 billion. So obviously we have no way to get there. And then if we start looking at more detailed numbers, right? There's over 5 billion mobile devices on the planet already today. Or actually, this is of 2 years ago, so it's higher than this now. And I think what's really interesting, though, is when you dig into that a little bit more, and you look at the fact that out of those 7 billion people on the planet today, only 2 billion of them are actually internet users. So we've only hit 2 billion internet users, and we've already used up nearly 4 billion addresses. So what happens when you get 7 billion people online? Is there any possible way to squeeze those into 4 billion addresses? And the answer is obviously no. And we're seeing that. 3rd of February 2011, the Global Pool, the Internet Assigned Numbers Authority, handed out their last 5/8s to the 5 internet registries. And they no longer have there's no IPv4 at the global level, right, as of 3rd of February 2011. Then about 2 months later, on the 19th of April 2011, APNIC, the RIR for the Asia Pacific region, handed out their last addresses. They're down to their last /8, so they've moved into their austerity measures. And basically, if you're in Asia right now, every organization can get 1/22, and that's it. Whether you're a new organization, existing organization, you get one more dip, /22, and you're done. And that's to ensure that new organizations can come in and set up CGN or whatever they need to do to connect to the legacy IPv4 internet while deploying IPv6. Just a couple of weeks ago, 14th of September 2012, we saw the next registry go down. RIPE is now out of IPv4 addresses. And again, they have a similar austerity policy to APNIC, so you can get 1/22 and then you're done. So obviously, IPv4 is running out. It's happening around the world today. And next up is going to be ARIN, and then LACNIC, and then AFRINIC, and these things are actually happening right now. So a more detailed look at this, we can see APNIC in the dark blue line there kind of just take a big drop. They've used up a lot of addresses really quickly in the last few years. ARIN there is in purple. They're coming up next to running out after RIPE, which we see the light blue line has already hit the bottom. And then LACNIC projecting out, as well as then AFRINIC is growing a little bit slower. So we look at this in a variance analysis, right? Both these graphs are from Jeff Houston. They're on podru.net in his tools area. ARIN is basically going to run out sometime in 2013, right? We don't know the exact date, but it's going to happen next year. LACNIC's right behind them, probably 2014. And again, the other thing is, when you look at these and you start putting these dates out there, obviously there's no one date that's going to work, right? We don't know exactly how fast things are going to grow. And what I'm hoping is your economies are all speeding up, everyone's economies are speeding up, which means businesses are growing, which means consumers are buying more things, which means you're going to run out faster than this. Okay, so these things could move in quite a bit, depending on how the economy works. And then AFRINIC probably 2015. So over the next 3 years, we are going to exhaust the rest of the addresses on the planet. So what does this mean for you? Obviously, LACNIC is not right on the edge right now. The people in Asia and the people in Europe are much more worried about this than maybe you are. They're much more unsettled, right? They get sick to their stomach when they think about IPv4 already because they're out. There's nothing they can do to grow their businesses. You may have another year or 2 years, maybe 3 years. So what that's done is it buys you a little time to do this without major expense. It gives you a little bit of a planning horizon where you can deploy IPv6 now, train yourselves on IPv6 now, and maybe squeeze in without having to go out and do some major forklift upgrades or really intense training right at the end, which is what's kind of happened in Europe and in Asia for a lot of companies. They got caught with their pants down. The bad thing with having a little bit more time is that it's fairly likely that the transfer market is going to be dry by the time you run out of addresses. So what's happening now, right, is as Asia, Europe, and ARIN run out of addresses, we've opened up transfer markets. You can actually buy slightly used IPv4 addresses on the open market potentially, or at least buy the right to use them. The problem is there's only a finite number of addresses out there available. Most of these addresses are in use. And the ones that are not are going to be purchased and put into use over the next couple of years. So it's very likely that although you may not run out for 3 years, when you do run out, it's going to be a harder run out than in other areas because there won't be any addresses to buy to backfill. The other thing is, global IPv4 exhaustion is obviously having a problem right now, right? Your web pages are not viewable only in Curaçao, only in the Caribbean. They're viewable all over the world. So things like tourism are especially affected by this, right? If you're trying to bring people in Asia into your country and they can't see the website for the hotels or the beaches or whatever else may be there, that's a problem, right? These are issues that are impacting your users today, even if you have IPv4 addresses available to you. The other thing I want to talk about is the fact that IPv6 is being adopted, is being deployed all around the world. So all around the world. We talked a little bit about these. Is being adopted, is being deployed so all around the world. The test was basically to see whether or not IPv6 could work. What we found is that most of the brokenness has been fixed, most of the operating systems and everyone else has cleaned up their acts, and it really does work. There weren't that many problems. A lot of people left it on permanently because of that on the content side. We followed that up this year, the 6th of June 2012, with World IPv6 launch. The requirement for internet service providers to participate in World IPv6 launch was to have 1% of their customers on IPv6 by the date. And we had several people who made it, and several who completely went way over this line. Home network and equipment manufacturers had to have a certain percentage of their devices available with IPv6 on by default, and to do that as the norm going forward. And then web companies as well had to have IPv6 on by default on their main www websites from then on by default. And like I said, we have thousands and thousands of companies who signed up and participated and successfully did this. If you look at operating system support, basically every major operating system today has a full IPv6 support. There are some that have some bugs still. For the most part, you can pick up any basic computing device with an operating system and use it on IPv6. Windows XP was limited. There were some definite problems there, but Vista and later, 7, all work great. Apple Macintosh OS X, since 10.3, has had pretty good support. The Linux kernels actually had support since 2.1.8, but if you want the most up-to-date IPv6 support, you really want 2.6 something or later to use today. There was some definite some bugs and some changes happening in the RFCs as the first kernels were written. FreeBSD, OpenBSD, all the BSD trains again for many years, since the late 90s really, have had support, and again the latest versions have full support. As we talked about earlier, Apple iOS from 4.0 and later had IPv6 support on Wi-Fi, and now the new 6.0 on the iPhone 5 has support on LTE as well. Android, we're still waiting for support on LTE, but the Wi-Fi interface has IPv6 support. So again, this is something it's no longer a fringe activity. This is something that major corporations, major companies all over the world are deploying IPv6 and have it built into their systems today. In addition to devices, network operators have deployed IPv6. So this list is just a select few that maybe have some bigger name recognition of the list, which is very much longer than this. Network operators that have deployed IPv6 in significant amounts. So all of these companies have a percentage over 1% of their users using IPv6, not just have configured them with IPv6, but are actually using IPv6 actively to reach websites on the internet today. DreamHost, Free.fr, KDDI, Verizon Wireless, Comcast, Time Warner Cable, and again, the list goes on and on. Many research networks and educational networks around the world have also deployed IPv6. And really, the last couple of years we've seen a huge uptick, and you can see that on this graph here, which is a third party took Jeff Houston's numbers and crunched them into this graph here. And you can see the green line there is prefixes that are announced on the IPv6 internet, and the red line is autonomous system numbers. And both of them, if you look, around 2008 it starts to tick up. 2009, 2010 is really where it starts to spike, and we're in that very vertical part of the curve right now. IPv6 deployment is happening right now today all over the world. This is another one, again, I won't go into these in detail, but home router standards have also been catching up. There's one place where there's been kind of a lack of support is in the home itself, right? Consumer electronics vendors have, for a long time, and even within the last year or so, I've gone into folks who make smart TVs and devices like that in the home who have said to me, we thought you were just going to translate the addresses for us, right? We could just keep doing IPv4 and you're just going to put a NAT box in there. We said, no, this is not happening. You actually have to deploy IPv6. And luckily they're catching on, right? So the Consumer Electronics Association now has an IPv6 working group. UPnP and DLNA both have task forces that are ongoing to add IPv6 support. And we're seeing this kind of across the board in the last 12 to 18 months, and then from here going forward, people have really woken up and seen the IPv6 light, so to speak. IPv6 only deployments. So a lot of people will tell you that it only makes sense to do dual stack right now, and that someday off in the future we'll be able to do IPv6 only. As of about 2 or 3 years ago, we've seen set-top boxes and IPTV devices doing IPv6 only. These are the ones that you know about publicly. A lot of this stuff is going on behind the curtains. There's a lot of IPTV voice over IP, many other deployments that don't have to reach outside of a specific provider's network, that they've moved to IPv6 only because they don't have IPv4 addresses left, right? So they're using IPv6 instead. And obviously, if you want to communicate with these devices, if you have any chance of writing applications or communicating with these devices directly, you have to speak IPv6 as well. One other thing that I think a lot of people overlook is that not only have companies and external agencies and device manufacturers deployed IPv6, but it's very, devices on your network today, which are using the automatic tunneling technologies that Christian talked about earlier, 664 and Teredo, to communicate with other IPv6 devices outside of your network. Now, from a V6 deployment standpoint, that's a good thing. From a security standpoint, not maybe the best idea. What's happening right now with IPv4 is if someone inside of your corporate network or someone on your service provider network wants to make a connection that you don't allow for whatever reason. Maybe they're trying to transfer, whatever the case may be, your firewalls are there to block that. Now, what if that same customer instead opens up a 64 or a Teredo tunnel? Well, now it looks like just an IPv4 piece of traffic. There's nothing on the surface of that IPv4 header that shows you that they're downloading illegal files or accessing child pornography in another country. And they can pass IPv6 traffic through that without you knowing. Without some kind of IPv6 aware, tunneling aware, deep packet inspection, this is happening right now in your networks and you are not aware of it. So by deploying IPv6, actually these tunnels stop because they're getting native IPv6 connectivity, and you actually see that technology happening. See that? It is carrier grade NAT. The pain is real. It's not a joke. There really are major issues with CGN. And what I want to talk about, though, is, let's see first, why is this line here is a supply of addresses assigned by the IRR. And this red line is the demand, it's the subscriber growth. So obviously every new subscriber that turns up on the internet needs an IPv4 address or an IPv6 address. They need an IP address. And so far, with IPv4 together, obviously when you run out of addresses, the address supply tops off. Now we're going to deploy IPv6, so if this is IPv4 only, we're going to deploy IPv6, so that demand will probably drop a little bit, right? Once IPv6 is actually fully rolled out, nobody will be asking for IPv4 anymore, but they are going to until then, right? When there's still IPv4, as long as space out there you pick up for a pretty good amount, right? They're going for about $10, $11 an address right now, so if you add that up to how many addresses you actually need, fairly significant. CGN might start to look a little cheaper then. So what we have here is this area where you're going to we're not going to have to deploy CGN here. It's going to happen in the rest of the world. Well, the problems with the connectivity don't affect just the people that are on that side of the CGN. They affect you as well, right? So if you're trying to connect to content or devices that are on the other side of a CGN device that another provider in another part of the world has deployed, you feel the same pain, right? As Mark talked about, I talked to a lot of service providers who say they're not going to deploy CGN. I talked to a lot of equipment vendors. They're saying they're selling a lot of CGN boxes. They're going somewhere, right? They may not be turned on yet, but it's happening. So you're going to see this, and then eventually maybe there's a 6RD step in there, maybe not. Then you go to native IPv6. And what we found is that advanced services are absolutely impacted. So video streaming sees some impacts. We see some problems with multiple Netflix streams and things like that. anything peer-to-peer is inherently broken. Some of the application vendors have found ways around this. They're turning it into a client-server model instead of a peer-to-peer model. So you think you're running a peer-to-peer application, the other thing is address reputation, right? So much of our, internet ecosystem is based on your public IPv4 address being your identifier, right? When you go to a website, it's a really good anonymous way to kind of track you. They don't have your name, they don't have your email address, they have your IP address. So if you're trying to log into your bank's website, they're tracking you by your IP address. These are real issues that are happening, or going to happen. Also, targeted advertising and geolocation, right? You like being able to, get customized services when you go onto Google and you search for something. The logging, right? What we've seen at CableLabs is if a CGN device is supporting about 50,000 customers, let's say, you're going to see average of 20 megabytes per second. Experience in IPv4. Web and email may work normally through a NAT device. Video streaming is going to be a little degraded. Peer-to-peer is completely dropped. Whereas IPv6, business as usual, right? Global end-to-end connectivity, no problems. So in the CGN space, we still have a lot of work to do, right? And really what we have to do is deploy IPv6. Because as Mark was saying, a lot of these things, right, security side and otherwise, IPv6 is still a fairly immature technology. We haven't deployed it, right? We have 20, 30 years of experience with IPv4 in commercial networks, doing production, quality service. IPv6, not so much. It's getting deployed now. A few people have some years of experience, but not everyone. So the level of quality of experience with IPv6 is coming up, and it's going to, we're going to see kind of the typical S curve as more and more folks get to know it, more and more vendors catch up, and while at the same time, your quality of experience with IPv4 is going to go down as more and more people deploy CGN. So we're calling this the experience gap, right? Where your IPv4 deteriorates before your IPv6 quality of experience comes up. And we're trying to minimize that, right? The sooner you deploy IPv6, the sooner you get knowledge and information shared about IPv6 within your organization, the sooner you have your beat on your vendors to fix those bugs that they had to fix in IPv4 for you in IPv6. We can shorten that. If we don't deploy IPv6, you're extending that experience gap, right? You're causing everyone more pain. So to kind of sum this up, IPv4 address exhaustion is happening around the world right now. As someone else alluded to earlier, the folks who invented IPv4 and the internet in general built it as an experiment. It was not meant to be scalable as a global commercial network. We can kind of eke it out a little bit more with CGN. CGN is, kind of a way to hobble along a little bit further, but you're going to see service degradation. You're going to see lower quality of experience. So truly, IPv6 is the answer to IPv4 address exhaustion. I'm going to go ahead and say it. It's 340 trillion addresses. In practicality, it's again, the individual addresses don't matter so much, but it's still somewhere around 16 million to 17 billion times larger address space in practice, right? And it fully restores the end-to-end principle. It allows for that permissionless innovation that we talked about yesterday. It allows for the internet as we know it to continue to grow. So it's time to deploy IPv6. If you're an equipment vendor, you need to include IPv6 in all IP-capable devices. And this is actually a best practice listed by the IETF and RFC 6540. Content providers need to start offering content over IPv6. If you don't know how to do it, CDN vendors can help, and they can probably help you with some other things too, as well as getting latency down and getting closer to your eyeballs. Service providers need to begin offering dual stack service. Enterprises probably have a little bit more time. You need to include IPv6 in your requirements, in your RFIs and your RFPs. You need to have IPv6 listed as a mandatory requirement in all new purchases if you want to be able to deploy IPv6 without cost later. And governments, I think we can take an example probably from Curaçao. They're doing a great job here with supporting the development, the outreach, and the training, and leading by example, right? Eating your own dog food, as Carlos mentioned. If you want to tell people to deploy IPv6, the best thing you can do is deploy it yourself. Any questions? All right, so we're all going to deploy IPv6 then?